Greetings to you all. My name is Martin Masheka. I am a science lemma at Zimbabwe Center for High Performance Computing, ZC HPC. That's where I'm working as an engineering research scientist. Thanks to you all sponsors. Right, our institution is located in Zimbabwe, which is in the southern region of the African continent. Yeah, that's where we are. Right, we are providing computing services to Zimbabwe and the region. So today I'm going to take you through what is supercomputing and parallel computing. So I will start by taking you to your normal life, where you say you watch movies with superheroes and a number of people doing several tasks. Right, this superhero, I can say a superhero is a human being with powers of more than one person. So a superhero is a person who is not normal because this person is having powers of more than one person. So this person can possess powers of more than one person. So that's the same with supercomputer. A supercomputer is a computer that has got more powers, or that possess powers that are at least equal to the powers of at least two normal computers. So in other words, what I'm saying is a supercomputer can complete and process complicated, complex, big tasks that require processing power of more than one normal computer. So that's supercomputing. All these computers, all these normal computers combined together to complete a single task that will be equal to one task completed by a single supercomputer. So a superhero, a supercomputer, a normal person, a normal computer. So combined powers of normal people equals to a superhero. And then combined powers of several computers equals to a supercomputer. So that's what a supercomputer is. Right, now I take you through parallel computing. In parallel computing, what happens is a single person will submit a job to a computer, and then a computer observes that no, I cannot complete this job by myself. I need help from colleagues. So what happens? It then breaks the job. The job is submitted by a user, and the user knows that this job takes time. It requires a lot of time. So the job is broken into subtasks, and those subtasks are computed or processed by several computers, and the output from several computers is then gathered and then displayed onto the output computer, and the user is now happy. So let me take you back to your normal life, where we have a garden, and we have a bucket and a tank of water. And let's say you want to water a garden with vegetables, but you need 4 buckets to complete this job. So the main job is to water that bed, with vegetables, and the job requires 4 buckets. So what happens? If you are by yourself, you need to carry 4 buckets. That is, you need to have 4 trips. So let's assume that each trip takes 5 minutes. How many minutes will you need? It's 5, 10, 15, 20 minutes. You will need 20 minutes to complete this job. Therefore, it's timeless. it requires a lot of time, and it requires a lot of endurance. So how best can you solve this job? How best can you solve this job? If you are a friendly person with some friends, what you will do is, instead of you going 4 times for 20 minutes, 5 minutes each trip, you will hire maybe 3 friends that will help you to carry the buckets. Each of you will have a bucket, and the 4 buckets are filled at once and then carried to the garden, and then we water the garden at once. 4 buckets, all the buckets are being filled at once, and you have your 3 friends discussing some issues, enjoying yourselves together, and all the buckets are then taken to the garden, and the water from all the 4 buckets are taken to the garden, and you are done with the task. You have reduced time from 20 minutes to only 5. You have reduced number of trips from 4 trips to only 1 trip. So that's parallel computing. And taking you back to computing, let's assume that we have images that needs to be processed, and then you submit this big job or big task to a single computer. And what happens with parallel computing is that these images are now divided into a number of computers or computing resources: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. So we have 5 computing resources, and then we have an output computer there. So what happens is these images are divided. Let's say there are 10. So let's say there are 100, and then 100 divided by 5. Then each computer will process 20 images, and then less time is going to be taken to do processing of all the 100 images, and then the output is then combined and sent to an output computer. So that's a parallel computing, parallel processing. I hope you have understood what is supercomputing, what is parallel computing or parallel processing. I thank you.